Good evening, everybody, and thank you for joining us. My name is Gemma Parish, and I am Head of Careers and Outreach at Shrewsbury High School. Can I just do a little bit of housekeeping, please? This meeting is being recorded, so please could you keep your camera and microphone switched off unless you are a presenter, and welcome to our panel. I know you're all with us now. Please, could I ask you to put the name of your school in the chat function on Teams? That helps me with my return for outreach, so I know how many schools we've reached. If you don't want to take part in the recording, please could you leave now? And if you do want to ask a question, could we ask you please to put it into the chat function? And then when we get to that part later in the evening, Mrs. Owen Davis will be asking those questions on your behalf. Just as an extra thing, we'd just like to mention that as this evening is all about engineering, which is a fascinating subject, we have a Shrewsbury High School alumni who is has been nominated for an award within the GDST. That is the link which I'll put into the chat. Her name is Emily Weaving, and she is an engineer, and so we'd like you, if you would like to vote for her, because we're trying to promote and obviously get her as many votes as we can. Sorry to our sister schools, but we are going to try and promote our own. So I'll post that link in the chat. If you would like to read a little bit more about Emily's story and vote for her, we'd be really grateful. So on that note, I would like to hand over to Mrs. Owen Davis. I'll just take myself off sharing. Hopefully I've got that right. Are you there, Mrs. Owen Davis?
We are here, Mrs. Parish. Are you okay to go?
Yeah, I'll hand over. Thank you very much.
Oh, thank you very much for doing that, and welcome everyone. Good evening. Thank you so much for being with us this evening. My name is Emma Owen Davis. I'm the Deputy Head Pastoral here at Shrewsbury High School in the GDST, and it's my pleasure to welcome you to our Women Mean Business event. This is our 6th event and focusing on engineering this evening. So thank you. It's lovely to see everybody's names popping up in the chat. So please do keep them coming. We're so excited that we can be hosting these events online, that we can reach more and more students, more and more girls, and more families and more alumni than ever before from across our GDST family. So I'm delighted to welcome so many of you to tonight's event. It's some of you from our sister schools as we celebrate our 150th birthday of the GDST this week. And such an important, obviously, movement in girls' education. If you're not with us in the GDST, then please do look out for us on social media and keep an eye out for those anniversary posts too. So whether online or in the flesh, the purpose of our Women Mean Business events is to raise aspiration and empower girls to head out into the world with confidence, competence and ambition. Over the course of all of these talks, as I mentioned, this is the 6th one, we hope to bring young women who mean business, all sorts of careers across different disciplines and businesses to share with you their stories, their expertise, their insights and experience. And we've got an amazing panel for you this evening. Tonight's talk focuses on women in the world of engineering, and we are very excited to be hosting a truly an impressive and accomplished panel this evening. We welcome tonight some brilliant women from across the engineering sector, each of them highly successful in their chosen field, and we feel very privileged that they have given of their time, which is precious indeed, to share their experiences and their wisdom with us. Each of them brings their own unique story and insight into what it means to be a woman in the engineering business. And for the young women joining us tonight as guests who aspire to a career in this area, this is the most fantastic opportunity to hear from those with those lived experiences. So welcome to all of you. We are so looking forward to you sharing your experience and expertise and offering advice to the young women who are with us tonight. We'll hear from each of our guests in turn, and then please can we save up all our questions until the end of the panel for discussion and Q&A. If there are any technical issues, please do bear with us, and we have a superb team behind the scenes who will get us going again should anything go awry. And so, to business. I'm delighted to start off and welcome Mivy James. Mivy is Digital Transformation Director at BAE Systems. She has had a career in software engineering since studying computer science and maths at Manchester University and learnt to code when she was 9. Mivy is an advocate for challenging stereotypes in the technology and engineering sectors. So I hope Mivy is there, and then the floor is yours. Mrs. Parrish, have we got Mivy? I hope so, otherwise I can start talking about and move on to the next person. Mivy, you are there. I'm so glad to meet you. Hopefully we can get you joining us because I would absolutely love to hear about your coding experience. Learning at 9 is brilliant.
On our way.
Brilliant. So we'll have Mivy with us in a moment. I'm seeing some more notes coming through in the chat as well, and we're going to rejoin on a different laptop. So I'll come back, Mivy, I'll come back to you, so don't worry. And I will redo your bio just before you start speaking, so don't worry about that at all. So I'm going to skip on if that's okay, and I'm going to go to our next panel member. So I'd like to welcome back, in this case, Dr. Alice Bunn, OBE, who has been into Shrewsbury High School recently for a speech day and to open a junior school. So Dr. Alice Bunn is Chief Executive of the Institution for Mechanical Engineers and a Shrewsbury alum. In her previous role, she was International Director at the UK Space Agency, responsible for increasing the UK's global influence in science, security and trade through space. She's married with 4 children, 1 dog and 1 cat, and Alice also has a PhD in metallurgy from Darwin College, University of Cambridge. Alice, thank you for being with us, and sorry to skip ahead to you. I hope that's okay.
Yeah, that's absolutely fine. Can you hear me okay?
I can. Welcome back. How are you?
Hey, that worked. Thank you very much indeed for that lovely introduction. So I'm just going to say a few words, I think, about my career history and then pass on to the other speakers. So super. Where to begin? So as you mentioned already, I did my GCSEs at Shrewsbury High School, and after that I went on to study maths, physics and chemistry A-levels. Went in to do a Bachelor in Engineering in Metallurgy at Leeds, a PhD at Cambridge. And I loved all that. I really did. I really enjoyed all that. But something that I kind of discovered along the way, palling up with a few of my colleagues doing a PhD, was the real joy that you can get from advocating for science and engineering. So we developed this little kind of science and engineering roadshow. We toured around a whole load of primary schools in Cambridge, doing kind of roadshows, really, really good fun. And you know, on the back of that, I kind of decided that research was great, but it wasn't for me. So I went on, and my first proper job, if you like, was working at the Science Museum, and loads of, you know, developing exhibitions, doing hands-on interaction, developing the collections there as well. And I really, for me, that was very, very rewarding indeed. And there I came across space. Now, for lots of people, and I get it, space is inspiring, inherently inspiring. For me, it's all right. Well, you know, it wasn't, you know, nothing wrong with it, but it didn't really float my boat. I had an experiment flown in space, and that was just really useful because gravity was getting in the way of what I wanted to study. I worked at the Science Museum in the Space Gallery. That was really useful because it brought all the visitors in. But the bit that I found really exciting was when I discovered about the real world benefits of space. And by that, I mean the huge contribution that space can make to environmental monitoring. So that thread of, wow, this is something that really matters, this is something that's really important, was, you know, really spoke to me, and I really wanted to make sure that, you know, I had a part of that. So I went on to start working with the research councils, initially looking at environmental monitoring from space, but quickly out into wider fields. And again, being at the coalface of seeing the real world impact of, in that case, scientific research and engineering, was a really powerful motivator for me. So I wasn't doing the research, but I was really pleased to be part of the team that was driving forward our science and engineering research generally. And I went into lots of different roles. One of my proudest roles was chairing a group of space agencies. So space agencies from around the world. We had the US in there. We had Russia, China, a bunch of countries in Europe, Japan, you name it, all collaborating because they recognized that even though we all had our own individual capability, our own monitoring capability, if you like, when we needed to use it for emergency response, it was really important that the right camera in space was at the right place at the right time. So there was a real benefit of working in collaboration. And you know, that got me thinking. I think one of the questions that maybe we'll come on to later, but that we were asked to think about in our opening remarks, was to think of a woman that had inspired us along the way. And for me, this is where I came across a lady called Barbara Ryan, and she was heading up a global environmental data sharing initiative. It had been running for about 10 years, and if we're honest, it wasn't that successful. The idea was right, you know, the premise was right, which is that environmental data, or what's happening with our climate, what's happening in our rivers and our oceans, you know, that doesn't respect national boundaries. So it's really important that we share that data globally. But the way it was being run was rather directive. You know, there was a guy, and it was a guy who was requiring organizations, public sector organizations, to share their data, requiring them to do it in a certain way, in a certain format, to a certain standard. And if we're honest, it wasn't having a lot of success. Barbara Ryan took it over, and from the get-go just took a completely different approach and was all about, how can I make this easier for you? How can I generate a system that enables it to be easy for you to share that data with others? So instead of creating this huge central, you know, repository of data, she effectively developed a whole series of protocols and sharing protocols, which made it easier for everyone. And that for me was really inspiring. That kind of thinking about a problem differently, thinking about it from someone else's point of view, fundamentally, was really, really key to success. So along my career, she's always stood out as a really, really inspiring lady. So gosh, yes, I spent most of my career in space, about 20 years in the space sector, largely working with the European Space Agency, so from the UK, but working as part of a bigger international collaboration. And finally, leading to my role here at the Institution of Mechanical Engineers. So I've been CEO here for nearly a year. And maybe I'll just help you make sense of that career, because careers are a funny thing. They always make sense in retrospect, but it's not very often that you have a plan at the outset. But for me, the real common thread has been, you know, support, promotion, advocacy, use what word you like, for science and engineering. Be that from promoting all the way through from primary age children through to supporting funding for academic research. And here at the institution, that really is our lifeblood. You know, our mission is to improve the world through engineering, which is pretty grand. But basically, the way we do that is through two things. Either we support our engineering community, our 115,000 members, to help them to operate at their best. More than ever, lifelong learning, that opportunity for upskilling and reskilling throughout careers is really, really important. And then secondly, to maximise their positive impact on society through helping them make the connections that they need to really make a difference. So I will probably pause there, if that's okay. I'm conscious that lots of others have got to come in to talk. That's my story so far. I really look forward to hearing others and joining the debate later.
Thank you so much. That was lovely to hear. Thank you. That's brilliant. And I will move on, and we'll have, as we said, some questions later on. So if you do have any questions to start with, do pop them into the chat as we go along. I'm going to introduce Mivi. Thank you so much for joining us. I'm so sorry about that. I introduced you and then we couldn't get you.
Yes, apologies for the technical glitch. If technology was very easy, I probably wouldn't have had a 30-year career in the tech industry. So it keeps me busy. So hi everyone, thanks very much for having me. So as you heard earlier, just before I dropped off with some technical issues, I started my real interest in the tech industry when I was 9, when I wrote my first code. But actually, I think my journey started before that. So although there's lots of routes into the tech industry, I think mine was quite conventional. The family legend goes that my dad made a bet with the rest of the family before I'd even started school, or possibly was in infant school, that I'd end up working in the tech industry, because apparently I took the back off the family TV to see how it worked. Much to everyone's delight, no doubt, because I don't think it ever worked quite right after that. So I started my career in the tech industry when I was 9. And I just sort of tell you this little story because I think it's very interesting to sort of think about how tech really helps us with our jobs. So back when I was a kid, home computers weren't anything like as popular as they are now. And I had access to a Sinclair ZX81. In fact, that's recently had its 40-year anniversary, and that really introduced computing into the home environment. And if you ask your parents about that, they'll tell you about analog TVs and how you sometimes had to kind of fiddle about with getting your TV working, nothing like the smart TVs that we have today. And if you wanted to play games, you had to write them yourself. So I learned to write my own games by badgering my parents to buy me magazines and then copying code into my little home computer. And I think it was over the Easter holidays, I had a very repetitive set of maths homework to do, and it was something like calculating if something had equal sides, what the angles were, and kind of we went up, and it was sort of something with 12 sides, 13 sides, etc., etc., what the angles would be. So I found this a little bit boring. So I wrote a program that took in, I put in how many sides the shape had, and it gave me the size of the angles. And so I kind of did that on repeat and copied it down into my homework book. What I didn't know was my dad had printed out my code, stuck it in my homework book, and then I got called to the front of the class and I could see this code sticking out. I had a little panic because in my mind I'd been cheating. And the teacher called me up, and I actually got a book certificate for being creative about my approach to homework and showing an understanding for technology, rather than my 9-year-old panic around cheating on my maths homework. And that really is sort of inspired me to really understand how technology can help us in our day-to-day tools. It can automate things. It can take something out of the process that's a bit repetitive, but also that kind of little anecdote just shows the importance of having supportive teachers. I've been rewarded for something that I thought was actually like a little bit rebellious, and maybe that's kind of set out my path since then. And then I went on to do, eventually kind of I went in to do my A-levels. I did all science A-levels, and I went to a school that perhaps is not too dissimilar to yours. It was an all-girls school in Bristol. It wasn't part of the day school trust because it had a small boarding house, and is now a mixed school, but that's where I did my A-levels. And I knew that by going down the science route when I went into university that it wasn't going to have a 50-50 gender balance. But I was quite surprised and disappointed by my first day at university as to how few girls there were who were going off to study computer science and maths. And actually, one of the things that really kind of inspired me down that route was hearing about a talk that one of my all-time kind of iconic heroes gave, Dave Stephanie, or Steve as she's known as, Shirley, and some of her career path in the tech industry. And she's still around today. She does definitely recommend looking her up. She's got a few talks available if you look her up on YouTube and things. And there weren't many women who were held up as sort of being big figures in the tech industry, and there still aren't, but she was definitely one of the pioneers. Quite recently, I was very pleased to appear in the British Computer Society magazine in an article alongside her. I felt like I've definitely kind of made it in my career. So I did computer science and maths at university. During the summer holidays, I didn't do the kind of jobs that other students do. I didn't work in a kind of a bar or anything. I worked as a coder. And when I graduated, I then went straight into a software engineering career. And over the years, I found that I was leading teams of people doing more in the design and less actually hands-on coding. And it's been a long time since I've actually written any code. So what I do now is I advise government departments, including the Ministry of Defence, including places like the Army and the Navy and the Air Force. And it was interesting to hear Alice earlier talk about her career in space, because on Tuesday I'm actually off to see Space Command, which is a real place, to talk to them about how they use technology and their data. So I do mainly advisory work these days, and I look at the strategy that those types of government departments have to make the best use of their data and their technology. And I do miss that hands-on coding sometimes because it's quite fun. And at the end of the day, you've got something that you can kind of point at that that wasn't there at the beginning of the day that you've made. So I liked that creativity. And I've always worked in the tech industry, so it's been almost 30 years now that I've worked in the tech industry, and I can't really imagine doing anything else. I'm not afraid of referring to myself as a bona fide nerd, and I really like the way that technologies never stand still. So how many of you have smartwatches and phones and things? So my smartwatch that I'm wearing right now is so much more powerful than that computer that I learnt to code on. I did calculate it, but it's something like hundreds of thousands of times faster, has way more storage. And that's just during my career. So imagine what things will be like in a few decades' time. And so it never stands still. And I really like the problem solving aspects. I also like the creativity. I think we tend to associate sciences and engineering with not being creative, and yet I have to be creative every day to find new ways of solving problems that nobody solved before, whilst also drawing on my knowledge, and also applying some sort of logical thought process to make very complicated problems simpler. And I really like the collegiate aspects. So I like being part of a team and working together to solve a problem. That really motivates me. I'm very motivated by working with other people and helping them solve problems, despite working from home a lot now. Being part of that team and having that team spirit is really important to me. And I've traveled quite a lot with my job. I've worked in Geneva, I've worked in Maastricht. The world's your oyster when you work in the tech industry. And I went to Seattle earlier this year to go to Microsoft's headquarters out there. There's sort of plenty of opportunity. It's very much a sort of a global career path, and there's a huge shortage of skills in the tech industry as well. So there's a job for everybody. I mean, like I said, I've had quite a conventional route, but you don't have to be a coder to work in the tech industry. And a lot of people go into coding and then maybe switch to another type of role, but they've got that fundamental understanding, which is really cool. And again, just like Alice, I didn't have a clear plan. I've not had a life plan to get to where I am. I'm very senior now. I'm very senior in a global organization. But I've always just done what's interesting. I've never stopped learning. I've always made sure that I am challenged by what I'm doing. So I'm only really thinking really half a step ahead. How can I stay challenged, and how can I make sure that I'm learning? I think that's it from me. That's sort of my career in a nutshell. But I really enjoy my job, and it's definitely a career that I'd encourage you to consider.
Thank you. That was fascinating. And I was jotting down loads of notes. I can see bits of questions coming through to me as well, so I'm sure we'll come back to them. Thank you very much. I'm going to hand over now to our next guest, if that's okay with you. And I'd like to welcome Rebecca Potts. I'm just going to tell you a little bit about her. Rebecca Potts is a graduate consultant in water risk management with WSP. She graduated from the University of Chester after studying natural hazard management and geography, and is currently working towards an MSc in flood risk assessment modelling and engineering. Rebecca, are you with us?
Hello, I'm just going to turn my camera on for everyone. Hello.
Thank you. I'll hand over to you, Rebecca. Thank you.
Hi, so I'm Rebecca. I've heard some fantastic careers on this call so far, and I'm lucky to be in a very early part of my career. So I hope that I gain the experience that you two who've just presented have gained. So I've actually just completed my master's now. So I have now got a BSc and an MSc. So a little bit about me. When I've always lived by the coast, and I've always loved coastal defences, coastal engineering. Had no idea how to get into it. I had no sort of guidance or sort of development from my school. So I took it unto myself to sort of look what's out there. And it wasn't until I applied to university at the geography department that I was told, from a geography point of view, it opened so many doors, one including coastal defence and water engineering. So it was one of those ideas that I thought, this is brilliant, I've got to get into this uni. So I attended Chester University and did geography and natural hazard management. Fantastic opportunities, a real varied course from biogeography to flooding, which is what I specialise in now. As part of my year 2, one of my modules was work-based learning, which requires you to go out and work 5 weeks for a company. So luckily that year I had a guest speaker from WSP called Mike Wellington, and he visited the uni and took us on a day trip to Talaca and Kimmel Bay in North Wales, which is where I live. Told us all about coastal engineering, a scheme that they just worked on as part of WSP, and I was just obsessed, loved it. Thought, this is great, what do I have to do to get into this now? So I contacted him knowing that I had a work-based learning module come up, and I asked, is there an opportunity for a summer placement that I could complete? And luckily they were holding out for a summer placement, and I managed to get onto it. After 5 weeks, I got offered a scholarship for my last year, which I was on the basis that I studied and worked for them afterwards. So when I completed my studies in 2020, I managed to get a job with them. Unfortunately, that was delayed because of COVID. So I didn't start until January last year. So I'm currently a year and a half into my career. And during that time, I was working towards my master's, which is what I've got. It's been quite a journey for me. I didn't know what I wanted to specialise in terms of water risk management. It was quite a varied career that you could go into. So I know one thing was I was obsessed with coastal defences, flood engineering, and hydrology. So I was given the opportunity from my colleague Julia, who works in Liverpool, to work on a flood alleviation scheme in Disworth, and it was part of Denbighshire County Council's flood alleviation scheme. And luckily I managed to create a flood model and get some hydrology and catchment descriptors for that, and contributed to their flood defence scheme, which now has reduced flows in a great way to stop the town from flooding. And that is sort of where I'm at now. I'm a level 1 hydrologist in my career. I'm doing some hydraulic modelling. I've done 2 schemes in South Wales for developments, housing developments, and I'm doing one in Ceredigion, which is another flood coastal defence scheme, which is one I'm really looking forward to. I also do flood risk assessments and drainage strategies. So I assist with drainage engineering and the drainage infrastructure team. So I'm a bit early on in that stage, but there's some fantastic opportunities coming my way. I was just invited to the Flood and Coast Awards for 2022, and that was amazing. It's sort of like the way I can describe it, a university experience where you go and you have a look at the different universities and what they have to offer. It was similar, but for the water engineering world. Fantastic experience. If you're interested in water engineering and flood risk management, it's something that's free in the exhibition hall, and there's some amazing talks that go on. Really interesting, and I was very lucky to be part of that and host WSP. So that's where I am at the moment. So thank you.
Thank you for sharing that with us. And again, we'll come back to you at the end with some questions that are coming in for you, if that's okay, Rebecca. Thank you very much. I'm going to move on now to welcome back Natasha Taylor, who has been in recently for our careers convention and is a recent alumna. Natasha is obviously another one of our old girls I mentioned, and is about to complete her degree as an undergraduate engineer at the Dyson Institute of Engineering and Technology. Tash completed her A-levels here at Shrewsbury and chose to pursue the degree apprenticeship route into engineering, successfully applied to the highly competitive Dyson Institute, securing a place on this well-regarded and prestigious apprenticeship. Tash, welcome back, and over to you.
Hello, thank you very much for that introduction, and thank you to everyone who's presented so far. I've certainly been inspired myself. I'm just going to attempt to share my screen because I was thinking it might be nice to have some visuals to talk around today. Hopefully you can see that all right. So, as Mrs. Owen Davis has just said, I am an undergraduate engineer, so I haven't actually graduated from an engineering degree yet, but already I feel like I've had quite an experience in engineering. So I wanted to take you back to when I was at Shrewsbury High School. Some of you may recognise a couple of either the spaces in these images or some of the faces perhaps. You can see so these are the experiences that I would say pointed me towards engineering during my time in sixth form. So you can see in the bottom left image here, this is in the physics lab at Shrewsbury High School, and this is our engineering education scheme project. So this is the first time I worked with an engineer. You can see him standing in the background, that's Ian. And Ian came from the automotive company Marla. And I think before this point, I hadn't really considered a career in engineering. But our challenge with Marla for 6 months was to develop a rig that would help on the production line of cylinder head covers. I'm not sure I'd ever really acknowledged a cylinder head cover before this project. So it was a bit of a challenge. And we looked at using some technologies which I was completely unfamiliar with. We were using laser systems for the measurements. But it was, even though we didn't completely finish the project in the time, the ideas that we handed over to Marla, the company, were some that apparently hadn't really been considered at the company because we had approached it with a completely different perspective. And I thought this was really interesting, that perhaps there was something I could bring to engineering that didn't already exist. Another engineering project I was involved in at school, which you can see in the other two images on this slide, was the electric car club. So you can see the car that we built from a kit in the bottom right corner here. And you can see the team of us, including the teachers. So you've got Mr. Payne, Mr. Lefebvre, and Mr. High in those pictures as well. And I found working with this team really inspiring. When Mrs. Parrish was talking about role models, for me, the people in this team really were role models because we all gave up our time after school to build this car and also to maintain another one that we inherited from another school. And to make it the best that we could, we really had to pull together. I think at times it felt like there was a lack of experience within the team. I know lots of people hadn't seen a spanner before we started this project, so making it to a track day to race against other schools was an achievement in itself for us. In fact, you can see on the front of the car in the bottom right-hand image, we had some changes to the health and safety rules quite shortly before one of our races. And they said that there had to be some sort of compressible material on the front of the car in case the car hit a pedestrian whilst in the pit lanes. And so we stuck expanding foam to the front of the car, and that was our solution. It really didn't take us very long. I'm not sure how many other teams thought of that as such. I think there were lots of complicated solutions when we turned up, but we were really pleased to have brought our new perspective and done something that others might not have thought of. When I was thinking about what I wanted to say today, I thought it was really important to show that going into engineering wasn't always the obvious option for me, because I think sometimes when we look back, as Alice mentions, retrospectively, it may seem like a really clear choice. So I just wanted to say I didn't do any conventional work experience in an engineering company other than the engineering education scheme coming into the school. I did my work experience in year 11 at Shrewsbury Hospital, where I worked with the Porter team because I thought I wanted to see what it was like to be a doctor, and I was too young to shadow a doctor at that point, and I hadn't started my A levels. So that wasn't an option. I did my work experience with the Porters, and I realized that actually one of the most interesting things in the hospital to me was how the Porters were able to use their system, which controlled the logistics of where they all were at any given time and how they were moving the necessary supplies between wards, seeing how that worked and understanding how that was helping people and getting people what they needed in a time frame that meant it was useful to the hospital staff was really interesting. I also really enjoyed being a house captain at Shrewsbury High School. The image in the bottom left is me and the team on sports day, which I believe is happening about now. And yeah, I really enjoyed that teamwork aspect because I felt that obviously even just the five of us could never have won that by ourselves. It was all about the whole team representing a quarter of the school, pulling together and working on in a combined way to achieve our goal. I've also included a picture of my dance class just before we went on stage for my final show. This was really important to me because it was an opportunity to be creative, an opportunity to do something a bit different. And as you might be able to tell from the picture, we were very much a team. And when I went on stage with all of them, it felt like, again, we were there because we had a shared goal. So I guess I'm showing you these images to show how part of my reasoning for going into engineering was the teamwork aspect. I also wanted to say, so I am essentially I perhaps should have said this at the start, the Dyson Institute of Engineering and Technology offers a degree level apprenticeship essentially. I'll come on to some of the details afterwards, but it's not the conventional university route. So I wanted to say that I considered several universities. You can see 3 of them at the top here. I was mostly looking for a university that would allow me to start off on either a general course or a course that would allow me to switch between engineering specialisms before graduating, because I was going into engineering without fully knowing what it was. I think I still had this question in my mind, what actually is engineering? So one way I thought I might be able to answer that question was by doing a year in industry with the same company that provide the engineering education scheme before going to university, because that was something they offered. So I had spoken to a company, I'd got an offer. I was going to go to an engineering consultancy company in Cambridge, but then I had also at the same time heard about the Dyson Institute. So I applied for them, sort of doubting whether I would ever get in. I wasn't sure. It was fairly new. The reason why I found out about it was because they were in the newspaper because their first ever year group had just joined. So it felt in some ways like a bit of a risk, but in some ways it was very exciting. So I thought I'd go ahead and apply and see what happened. And this is my year group. So I got in, you might be able to see James Dyson in the middle there. This is us on the Dyson campus, which is based in Malmesbury. fairly close to Bristol and Bath. So I was really pleased even just to be there. So I'm in my 4th and final year on the course here. I was pleased that in the 1st and 2nd year, we study a general engineering syllabus. So the modules include things like maths, electronics, mechanics, software modules, so programming, and we also rotate around workplace teams. So in my first 2 years at Dyson, I experienced 7 different teams. They've changed it slightly now. So over the first 2 years, if you were to do it now, you'd only actually go into 4 teams. But when I was there, I did everything from I did structural analysis, where I looked at the force to open a vacuum cleaner bin. I did things like I went into a motors team where they were looking at the electronic controls of a motor. I briefly worked on the Dyson Automotive project, so the car project that was running at the time that's unfortunately stopped now. But it was a really interesting experience to see how so many different people worked and all the options that were all considered engineering. Everyone there was an engineer or a scientist, but they all worked in such different ways. I should say the images I've put up on the right here are the pods that we lived in first year, which were very exciting because they are student accommodation, but they're a little bit unconventional, which was excellent to see, feat of engineering in themselves. So then I moved on to my 3rd and 4th year here. So in years 3 and 4, we get to choose a stream. So I chose the mechanical stream because I'd really enjoyed our thermodynamics modules. I went into the aeroacoustic turbomachinery research team, which is a mouthful. But essentially what that means is that I look at the aerodynamics, so airflow, and the acoustics, so how loud products are, relating to turbomachinery. So what you can see me playing with in a lab in the image on the left is a rotor that goes inside our Dyson fans and generates that airflow through the product. So we're looking at making that spinning part generate airflow as quietly as possible so it doesn't disturb customers. And I've been really enjoying that. I am submitting my final year project final report tomorrow morning, which is very exciting. That's the last part of my degree, and that will then be over. But I should say that throughout this degree, or at least from 2020, I have been working towards setting up a Women in Engineering Society at the Dyson Institute, which was an opportunity for us because there hadn't been a Women in Engineering Society before, because the Dyson Institute is so new. As I said, I'm only the 2nd cohort to have joined. So I worked with Cora, who's on the left of the image on the right, to found the society and to get affiliated with the wider Women in Engineering Society network, which was exciting, but also a lot of forms. And then once we'd done that, we formed an organizational team who you can see those that were on the team for 2021 to 2022 in this image. And we really enjoyed being able to outreach with school groups, to run our own activities and to get our own guest speakers in. And I think this was really important to me because this element of teamwork going alongside everything I was doing in the workplace and studying at the same time was something that really completed the experience for me. I've just thought I should perhaps mention what my next steps are, as I've kind of led on to that. So I will graduate in October after I've completed my apprenticeship qualification as well. And then I will be staying on at Dyson, but taking a break to do a 3-month sabbatical and then working for the Dyson Singapore offices. So we've been given the opportunity to travel, and I'm really looking forward to taking that opportunity. But yeah, that's all from me. Thank you very much.
Thanks, Tash, and thank you for being with us when you've got the deadline tomorrow as well. Very impressive. So I'm going to go and last but far from least and hand over to our next speaker. And please do keep thinking of your questions too for our Q&A in a moment. But I'm going to go over to Kate Melvin now. Kate was actually, until a recent wedding, congratulations, is a manufacturing shift leader for Johnson Matthey in Clitheroe. She completed her Masters in Chemical Engineering at Cambridge University after completing her 5 A-levels, I'm told including A-level Chinese. In her spare time, Kate enjoys volunteering with the Guide Association and being outdoors. And Mrs. Parrish said also spending time with your new husband, Kate.
Thank you. Yes, yeah, this is only my my second week back, so yeah, married life is all very new. I think I'm probably still Kate Ashley on Teams. I'm sort of half and half at the moment. So yeah, I at the minute am a manufacturing shift leader, so not actually an engineer at the moment. I will talk a little bit about how I got here now, I guess. So I did A-levels, maths, further maths, physics, chemistry at a previous school that Mrs. Parrish worked at, and I think at that point I kind of didn't exactly know what I wanted to do. My dad works in like chemical law, so I sort of looked a little bit about what he was doing, but actually found the science and engineering that he is in far more interesting. So at that point I'd sort of decided on some sort of science career. It was always going to be something involving maths or chemistry, but I actually had a brilliant chemistry teacher when I was at school that really opened my eyes to the whole chemical industry and all the different options and things that go on there. So that kind of inspired me to look at chemical engineering. So I also was really lucky to be able to organise some work experience at actually the site I work at now, like 10 years later. So that was brilliant to get a feel of what engineering actually is, because it's not exactly something you study as an A-level necessarily. So I got a bit of a taste of what the chemical industry was like, and met a couple of really brilliant female chemical engineers then that were really like carving out their path in what can be quite a male-dominated industry. So that kind of inspired me to push on with chemical engineering, and with the support of Mrs. Parrish and everyone else at Bishop Heber, I got a place at Peterhouse in Cambridge to study chemical engineering. Again, another course where you get a generic first year to dip your toe in a few different options. So if I'd have decided that chemical engineering wasn't for me at that point, that would have given me chance to go in a different science or engineering direction. But I decided that yes, chemical engineering was what I wanted to do, just because of the chemical industry, the manufacturing industry, and the huge wide range of stuff that we get up to. So I had exposure to the industry that I'm in now. So Johnson Matthey make catalysts. A third of all catalytic converters in UK cars we made. So there's a chance that you've driven around with one of our catalysts cleaning up your emissions without even knowing about it. But other chemical engineers, I've got friends that work in the automotive industry, that work in the food industry, sanitation, and then all the standard kind of oil and gas image that you have of manufacturing as well. The other great thing about chemical engineering, I think, is that it opens doors for all sorts of other things, like myself not even being an engineer anymore, but I've got friends that work in the city that have gone into finance and that have gone into all sorts of different management things. So it's a good choice for keeping your options open, is chemical engineering. So yeah, when I graduated, I got a place on the graduate scheme at Johnson Matthey. where I'd been for my work experience already. And so I spent, or the plan was to spend my first 4 years touring around different chemical engineering disciplines as part of Johnson Matthey. I realised after my first year that the options I had weren't massively inspiring to me. So one of the best things I've done in my career is just take a hold of it for myself. And I got in touch with a few different people at different sites and managed to find a work placement at a different Johnson Matthey site down in London, which is actually a recycling refinery for precious metals. So that was something completely different. I was on the safety team there, and it was pretty cool to walk around, and there was just kind of drums everywhere full of hundreds of thousands of pounds worth of like platinum and gold and palladium and all sorts of things like that. So that was a bit of a bizarre experience, and working in process safety was absolutely fascinating, because you realise the chemical industry, the nuclear industry, I actually feel far safer at work than I do driving my car or anything like that, because I know what's gone into the background of this sort of thing. So that was really, really interesting. But actually, I decided my heart was still in the northwest. So I've ended up back in Clitheroe in Lancashire, back at the site that I came to work to my work experience placement when I was 16, 17. I worked for a while as a chemical engineer, looking after production plants, working on safety projects, things like that. But I actually really fell in love with working with people, and working with teams. And actually, I find it really rewarding to be able to improve someone else's quality of work and quality of work life. So that kind of took me down a path away from hands-on engineering and into management. And so now I work as a shift leader. So I work nights, I work weekends, but I'll also get a whole 10 days off every 5 weeks. So it's a great career if you want plenty of holiday time. But it's so I've got a team of 9 guys that are all wonderful. I'm the first female shift leader, I think, on site ever. Certainly the only one at the moment. So I'm also the youngest person on my team. So quite an interesting set of challenges to gain respect in a definite as a minority, and as perceived someone that's quite inexperienced. But I think the things that have really stood me in a good stead to do this has been just making time for all the people that are around you. At the end of the day, if the people around you advocate for you, you're going to go a long way. So I think it's really important to take time out to look after your peers, your team, and just build some really good relationships. Another thing I'd say is don't be afraid to try something completely different, or something that's not been done before. If you think you're going to enjoy it, just go for it. If it's something you're passionate about or can get excited about, you're going to have so much more fun in your work life, and that's really going to show through, and people will promote you because you look like you're having a great time and that you're passionate and you're excited about what you're doing, and that really shows through. So yeah, find something that you absolutely love doing and hold on to that. And if it turns out the thing you thought it was isn't what you thought it was, just do something different. I don't think I'd have ever thought when I was sat at school sort of 12 years ago that I would be in charge of safety out of hours on a chemical site that makes thousands and thousands of tons of chemicals a year. It was entirely unplanned, which sounds like a bit of a theme amongst some of the speakers here, but I've actually found something that I love doing, and I still get to use my engineering skills, certainly, and some of my engineering background a little bit still. But yeah, it's definitely a door opener to just finding something that worked for me and that I love doing. So yeah, I think that's pretty much where I am right now. I think looking forwards into the future, I'd love to go and run a chemical site one day. I'd love to be a site manager, but definitely something people focused and working in teams. Hopefully still with a hint of engineering in there. But yeah, that's where I'm up to. So I'll hand back over.
Thank you so much. That was really interesting. I've got questions coming in all over the place. So I'm going to start off with my first one. Thank you very, very much. So this is going to the panel, and it was if you were asked to describe your branch of engineering to an A-level student, how would you do it? Any takers for the first one? So if you were asked to describe your branch of engineering to an A-level student, how would you do it? Mivi, I don't know if you would mind starting us off on that one.
Yeah, sure. It's an excellent question, because I think my branch of engineering is quite abstract, in that it's not you're not building a physical thing, you're building a logical thing. So the way that I describe it, I mean, you call it sort of software engineering, is what you're engineering is some instructions for a computer or a set of computers to follow, largely to process data. So it's takes data, you apply some really interesting algorithms to it, and something else comes out at the other end. I mean, that's an oversimplification, and there's a lot more to it than that. But it's a very sort of abstract type of engineering, and you can do it from anywhere. So like I could do all of my engineering and never leave this room if that's what I wanted, but I do like going out and about and seeing people for real. So you could maybe kind of characterize it as potentially armchair engineering, if that's the kind of career that you're after.
Thank you very much. I'm going to pass that on, thank you, over to Alice. What would you say to this A-level student? And Mrs. Parrish has asked me to ask the panel to turn your cameras on. Sorry, I didn't realise I missed that on my housekeeping. Alice, what would you say?
Oh, what would I say? Well, of course, like CEO at the Institution of Mechanical Engineering, I'd have to say it was mechanical engineering. That might not help as an answer, because mechanical engineering itself as a discipline is so broad. It's stuff that moves, right? And if you want to know about stuff that moves, then you want to know about the materials that the stuff is made from, so it doesn't break. Probably it's not manual anymore, probably has massive contribution from Mivi and colleagues in her sector, because really you don't get, I think the answer is, it's very, very unusual to work in a single engineering discipline these days. You're going to have a tendency, you're going to have a strongest suit in one particular field of engineering, but generally the boundaries are very blurred these days. I think, you know, you will have to know about electronics and software inevitably in what you're building. You will also have to understand about materials. You will have to understand about sustainability. You'll have to understand about economics. There's this thing going to wash its face as, you know, a business proposition. You'll have to know about finance. So I think, you know, by all means, go where your heart leads you in any individual discipline, but always be open to the fact that you're going to need to know about other different types of engineering or disciplines outside of engineering to really, you know, be successful.
Thank you. I'm going to pass that over to Tash now, because what do you think if you were coming back and saying, you know, you've recently done that in our careers convention as well? Did you have to answer that question specifically?
Not exactly that question, but I suppose talking about what I do on a day-to-day basis is fairly similar. So Alice has just described what it means to be a mechanical engineer, and I would say, having chosen the mechanical stream, that I am also a mechanical engineer, but would agree that that broad base is really important to understand other disciplines as well and see how they interact with what you do. But as I said before about being an aeroacoustics research engineer at the moment, which I would say is very much at the moment. I haven't necessarily tied myself into that for the rest of my life. I currently look at how air flows and what that means for the noises it makes. So we talk about pressure a lot and pressure gradients and how we can use that to our advantage, and then how much noise is going to be associated with doing that sort of thing, but all within the context of turbo machinery. And for us, turbo machinery is about things that spin. So we use the fact that we can put something on the end of a motor and spin it around to generate pressure without generating too much noise, which is actually quite a similar concept to things like wind turbines that everyone's probably familiar with. So we, use aeroacoustic turbo machinery in lots of different industries, but for me, it's in fans, basically fans, heaters, purifiers, and that sort of thing.
Thank you. Kate, same question to you.
So I guess if you imagine your chemistry practicals that you do, but imagine you're working in pots that are the size of your house effectively. You probably can't just quite see the tanks behind me outside the window. But I take that that workbench scale of chemistry and run it in massive volumes, thousands of tons, to generate chemicals that make the world go round effectively. At that sort of scale, safety becomes absolutely critical, keeping people safe, keeping the environment clean. You can probably, I'm still in my high vis overalls. I've only just finished work today. But yeah, I think it's growing your benchtop chemistry to an unimaginable scale nearly, and making sure we do that safely and ethically, and by taking care of the environment as we do it.
Thank you. And Rebecca?
So I think water engineering is a broad term. You might think of it as, what is it? What do I do in water engineering? What can I do? And it is very varied and broad. So I am a trained hydrologist and hydraulic modeler. So that is one part. Writing flood risk assessments is another part, and drainage infrastructure, drainage strategies are a different part. And we all sort of, I think one part is we all work together. There is no one thing in this type of career that doesn't work with another. We're all intertwined, which is, I think, a big thing, especially with net zero going on, sustainability. We're all working together to achieve the same results. I also do a lot of work. I live in Wales. I do a lot of work in Wales, and we work a lot with policy and the Welsh Government on flood risk management. They've got there's council documents that you can help work on. So strategic flood risk assessments and preliminary flood risk assessments. And they also have a huge sort of varied engineering part in them. It is quite a broad topic, but it's something that you can, if you have an interest, you can definitely delve into it into many different ways.
Thank you. I think one of the questions I've got, some coming in from various places, so please forgive me if I'm looking at different screens and things. But one of the threads that seemed to be running through everybody was talking about creativity and different ways of looking at problems, and the way that actually that kind of, that collaboration, that creativity was needed across everybody. And maybe I think you mentioned it with that creative approach to problem solving. Would you mind saying a bit more about why that's so exciting?
Well, I think it's important to talk about creativity, because I think it's very much a cultural thing that we have in the UK, that you're either scientific or you're creative. And one of the things we haven't really touched on is it's in our society, it's fine for people to kind of express themselves and go, well, I'm very musical or I'm artistic or creative. But if you say I'm good at maths or I like science, people look at you in a slightly strange way, which is, you know, why I say I'm a nerd and I'm not ashamed to be a nerd. And I'm very keen for us to remove that stigma. I don't see why it's something to be frowned upon, and it shouldn't be something to be embarrassed about. So it's kind of like a bit of a soapbox moment for me, if you like. And they're not, it doesn't need to be either or. You know, I solve problems all the time, and I take complicated problems and make them a bit simpler so that teams can get started on them. That requires creativity. I do a lot of what we would call lateral thinking. So, you know, I'm kind of joining the dots between what we see over here and what we see over here, and kind of figuring out how we can actually go a bit faster or reuse something in a different context. And we talk a lot in the technology industry about innovation. You know, I think I've talked about how, you know, how much technology changes. So there's this constant innovation, which is a type of creativity. And then there's actually the actual sense of creativity itself. Human beings interact with technology. It's got to be easy to interact with, and it's getting easier and easier. And so I work with a lot of colleagues who actually have creative as part of their job title, and it's to make it very easy to understand. So you don't have to be a maths graduate to actually interact with whatever the machine's doing and those algorithms I was talking about. So there's this genuine kind of interaction and kind of making things visually appealing that people are drawn to and want to use. If you think about the apps on your smartphone and stuff, there's lots of creative people involved in that as well. So it's kind of a whole mix of things, but the main reason why I go on about it is because I think it's really important to not see those things as being an either or.
Thank you. And I can see Alice nodding furiously away on the screen as well, because can I come over to you next?
Yeah. Oh, yeah, I'm right. Yeah, everything Mivy said. But also I would add something. I think it's really interesting, isn't it? When we talk about science and engineering in particular, sometimes we just sort of bundle it together. Science and engineering, STEM, it's all the same thing. And I think something about engineering, as well as that creative streak, there's also a tremendous pragmatism to it. It's a really practical thing. Science can be quite ponderous. Engineering is making something happen. So, you know, we had a really good example in the, you know, where I work now during the pandemic, actually. So you had that bit at the beginning when, wow, we had this new virus and it was all quite scary and quite odd, and we didn't really know how it transmitted. We didn't really understand what was going on. We didn't understand the impact on our body. We didn't understand, you know, there was so much, and we mainly washed our hands, right? And we're quite fixed on surface to surface transmission. So we had a bunch of people in, you know, engineers, ventilation engineers in the institution who quite early on said, do you know what, this could be transmitted in the air, this could be particle transmission. Now, they quickly realised that UV kills viruses. Right, that's not new science. We actually knew that 175 years ago. But you've got to take that scientific knowledge and make something useful out of it. So what can you do with that? And that's when you really needed the engineering skills. You needed to understand the viral load in the atmosphere. You needed to understand the kind of throughput of air that and the length of time that the air needed to spend in that UV environment to kill the bacteria, the virus rather. You need to understand, you know, what kind of equipment would fit, what scale of room. So all of that is really, really practical. It's taking something the way you know the science works, but applying it in an environment. And they did this amazing thing before Christmas where one of our engineers is the chief engineer at NHS, and they worked with the NHS to basically develop the standard for using these UV sanitizers. And they did that by conducting trials where, you know, day one, the hospital wards full of virus, full of COVID, day 5 of having the right standard equipment in place, and there was absolutely zero virus in the atmosphere in the ward. So really powerful impact, but really practical, as well as that creativity point that I think Mivy's made really well.
Thank you. I'm going to follow up. I'll come back to creativity because there's a few ones pinging through about that. And as you're talking, people are getting inspired. But there's a question on the chat that I'll take to you, Alice, if that's okay while we're with you, which was how else can we use space technology to aid our quest in tackling climate change other than data research? And I thought, can we elaborate on that a little bit?
Spoiler alert, I could talk on this for hours. Yeah, so I'm going to try and be to the point. So I guess first point, understanding. So we only understood the greenhouse gas effect, you know, as a warming effect on our planet through the study of the atmosphere around Venus. So understanding is really important. We continue to apply that understanding, in particular recently, on the impact of methane. So that was something, you know, that was coming out loud and clear at COP26. Lots and lots of focus on actually methane is a really, really powerful contributor to greenhouse gas warming effect. There's some fantastic observations that you can take from space. There's a brilliant company where they're really careful not to set them up as the sort of policemen, but they've been so effective in identifying massive scale industrial emissions and being able to say to those companies, hey, you might not realize, but at this stage in your production cycle, there's a massive belch of methane, and you want to look at your process and you want to do something about that. So that's been really effective. Through to a lot of oceanography, a lot of our understanding of the oceans is enabled from space as well, because they're such vast scales. So we can understand now the El Nino effect, the change in the tides at the coasts in particular, what we need to do for coastal defences, how the salinity of the oceans affects that. This is the point where my kids go, shut up, mum, you cannot tell how salty the sea is from space. Yes, you can, because it affects the signals that are bouncing off the surface. And just final example, so much. It's a brilliant program that one of the proudest things actually, which was using our aid funding to support space programs, which was very controversial at the time, because people think of space and they think of rockets and missions to the moon and all that shebang, national prestige, all that stuff. Actually, most of what we do is down to earth benefit. So we set up this program working with Vietnam. We worked out that if you could get a really wide scale view of water levels, you could correlate that with mosquito outbreak, you could correlate that with the outbreak of mosquito-borne disease, and then you had a sufficient planning timeline to be able to mobilize local health units to help control the outbreak of things like Zika disease. So much which in itself is related to what's going on in the climate. So much, but I could talk all night, so I'll shut up.
It's fascinating, thank you. And then they're flooding in, and no pun intended, with it, but actually they come through and people say, well, Rebecca, what do you think on that from what you're talking about, Alice? Because actually it naturally comes to you with your experience, Rebecca. What would you say in response to that?
I just heard you say that and I thought, oh my God, that's amazing. That's something that's right up my street, hobby wise. But that's actually a really interesting take on it, from a coastal defence viewpoint as well. It's, something that's I would have never thought about. It's something certainly my industry's not thought about in terms of, well, my office or people I know, but that's really interesting actually. Something worth incorporating, to be honest, as well.
I think, Kate, you mentioned sustainability, and that was something that I jotted down while you were speaking. Is this something that kind of speaks to you as well, while you're here in the panel reflecting on that?
Yeah, definitely. So we work with a lot of nitric acid. So one of the main environmental emissions we have is NOx. So it's massively important to us. The NOx is such a potent greenhouse gas. It's massively important to us to minimise that as much as possible. NOx is fundamentally tied into how we do our processes, but actually the efficiency of our scrubbing systems is so important to limit that as much as possible. So it is vitally important to me to properly understand how much NOx that we're generating at any one time, and how efficient our scrubbing system is to minimise any environmental impact to what we're doing at all. So in terms of the manufacturing side, that analysis of how we're affecting the environment is massively important, and actually projects to try and improve the efficiency of cleaning up our gas streams is massively important. our site is in the most beautiful valley in Lancashire, and it kind of brings home to you how important it is to minimize the impact on our environment at the same time as creating so much benefit. The products we make massively help other industries clean up their emissions to work more efficiently. Like obviously catalytic converters are huge to reduce the impact as much as possible in the automotive industry. But that doesn't give us carte blanche to create these things in an unsustainable way. So I do lots of monitoring to keep track of where our emissions are, also our water usage, our energy usage, and it's a huge part of my day to day to try and reduce the impact of what we're doing as much as I can.
Thank you very much. I've got a different question now, Tash, that's coming to you, if that's okay. And it was a question saying, do you feel you've missed out on, I'm going to say like this, university experience by going the pathway that you have? And would you mind telling us about that?
Yeah, of course. I would say I don't think I've missed out. When I graduate in October, I will be graduating with, I think, 38 others. And we've had this shared experience all together. It's a smaller group, yes. In fact, it might be more similar to what you might expect at a school or college in terms of size, but we've still had lectures from lecturers for 2 days a week, or at least study time and labs that have been removed from the workplace. So we study in a very similar way to what you might expect at a university. And also the student community is big enough to do things like having socials and to have societies. I mentioned my involvement in the Women's Engineering Society, but I'm also part of Adventure Society, which is an umbrella term that includes things like a climbing group and a walking group. So we do still do all of those social activities. Yes, it's slightly different, but I would say in some ways it's different because it's more personal. And it's rare that you walk down the corridors in the academic spaces and see someone that you don't recognize, but I quite like that. And there are still plenty of people that you can find people with similar interests to you, especially because as a company, we also have interns and graduates who are pretty similar in age to us and allow us to expand our network. So we have all these intern and graduate friends that are spread across the Dyson business and can be really useful to know at work as well. Because when you need help with something, you can think, actually, do you know what? That person who shares a hobby with me also knows exactly how I can solve this workplace problem.
That's brilliant, thank you. I've got another one that's come in, and it's just what I'll ask this to the panel as a whole, but Tash, feel to continue with it if you think it'd be good to carry on, which is, what do you think is the best way to get into your field of engineering? So that's the whole panel. And do you think apprenticeships are the way forward? So Tash, if you continue, and then we'll pass it on, if that's okay.
Yeah, of course. I guess I'm here because I want to promote apprenticeships. I think it's worked really well for me. The main reason for me doing this was because I didn't know what an engineer did on a daily basis, and I figured the best way to find that out was to dive in and do it. And I would say I feel a lot more prepared to answer that sort of question now. I can confirm I do know what I do on a daily basis. And I think it means that we also have we have a network of engineers that we know. So we have loads of people we can get advice from, as well as practical experience. I think I'm so much more well set up than I would be if I'd gone to a conventional university, because I think I've learned more from the workplace than I have from the degree aspect. The degree gave me that theory and some technical knowledge, but I've expanded it so much further by going into the workplace. So yeah, I would absolutely recommend it.
Thank you. Miffy, what would you say to that? What's the best way to get into your field? Thanks, Tash.
I don't think there's a single best way, actually. There's definitely not a one size fits all. And we're facing a digital skills crisis globally at the moment, and particularly in the UK. So I think any route that people take in, I'd definitely embrace. In my company, we hire people through what you might call the conventional routes, the sort of graduate recruitment routes. but we still train them when they join the organisation. We also have apprenticeship schemes for all types of engineering. So the company I work for, we build ships and submarines and planes, as well as the type of engineering that I do. So any of those fields, you can come through an apprenticeship scheme, and we're looking to extend that, particularly with a digital focus, because we've been doing the other types of engineering for a long time. And we also hire people in through other types of routes. So we work with external initiatives aimed at, there are lots of things out there to get people into coding at any point in their career. So you don't necessarily have to come in straight from school or straight from university. There's actually a lot going on now to bring people in as experienced hires who may be looking for a career change. And some of those routes, we've had people who've run shops for years, are in their 50s or 60s and are training to be coders. We hire a lot of ex-military people who are moving into a different industry, and ex-police officers and things as well. And there's a lot going on as well to attract women into the tech industry who maybe have not previously considered it as a career, and also to bring women back in who may have left the workforce to care for children for a number of years, for example, to get them back in. They may have worked in the tech industry before or not. So there's so many different types of roles. I actually think you just need to find what's right for you. There's no single answer. Like I said at the beginning, I went through quite a conventional route, straight from school with I think somebody else with the same A levels on this panel as me, maths further, maths, physics and chemistry, on to do computer science and maths at university, but that's not necessarily the route you need to go down to get into my career.
Thank you. Alice, how would you add that? Thanks, Vicky.
Yeah, lots of different routes. And, it's really wonderful to hear Tash advocating for apprenticeships, because I really think, apprenticeships have a very, very strong role to play in fueling the engineering workforce of the future. I think for a number of years, government in particular was a bit hot and cold on apprenticeships, but it really feels like apprenticeships are here to stay now, which I think is wonderful. Many different routes in, classic university routes. There's also an increasing need for engineering technicians. I mean, I think this is it. As society moves on, as we continue to innovate, the types of engineers we need change as well, or the balance across the type of engineers that we need change. And I think that's particularly important, not only as you enter the profession, but actually throughout careers. So increasingly, we're seeing that, need for upskilling, reskilling. There's a fantastic thing going on in the northeast of Scotland at the moment where, once absolutely the home of the oil and gas sector, they're really reinventing themselves as, thought leaders for renewable energy production. And, turns out the kind of skills you need to build, an oil rig out in the middle of the North Sea are not in that many respects different to what you need for a wind turbine. So there's so much, transferable skills that go on there. So I think, any route is good, and also definitely take the perspective that you can change as things go along. I always cite this kind of famous statistic, which you can probably chuck stones at, but it's near or there. 85% of the jobs that we're going to do in 2030 are unknown today. And I think that's a really staggering thing just to kind of think about for a moment. And why is that staggering, and why is it largely true or thereabouts? Because of all the innovation that's to come, because of the way that we will change how we live our lives. So, keep agile, keep curious, keep being prepared to think about new opportunities is as important as your initial entry route into the profession.
Thank you. I've got a kind of a follow-on question to that that's specifically for Rebecca and Kate, if that's okay. So if you're thinking about along these lines, I've got a question about jobs with work placements, and would you recommend this? And in terms of the way that the courses you've picked and that kind of pathway, kind of leading on from that. If I start with Kate, is that all right?
Yeah, absolutely. I think my work placements, my work experience from school through to my summer placements through university gave me so much more confidence that this was the sector I wanted to be a part of. I think one of the problems with engineering is that it's not your standard A-level subject, and I think it almost feels more secure to study chemistry because you've learned what chemistry is, and leaping into something that's titled differently can be a little bit daunting sometimes, and a little bit unknown and a little bit out of the ordinary. But actually, grab onto any opportunity you get to get out into industry at any chance you can. It gives you so much more idea about what being in engineering is all about, and there's so much more out there than any of you will imagine right now. I never saw myself with this career path when I was 18, and getting into industry early gave me a little bit of an inkling about what it might be like, and I grabbed onto an experience that I really enjoyed and ran with it, and that's kind of took me to where I am today. But equally, I spent some time in an industry that I didn't particularly enjoy, and that all taught me just as much about things I didn't want to do with my career. So it's definitely okay to try stuff and decide that actually something else suits you better. And I think it's all about what suits you as an individual, and the route you take, or the things you study, or your graduate job, or your apprenticeship route massively don't matter in even, I mean, at 8-10 years time for me, and things change so much. And as Alice said, the jobs that will exist in 10-15 years time, we don't even know them now. So we're not in a world now where you graduate with the job title you're going to have when you retire. And I think the only way to experience that is to just try stuff, in your career, but definitely at the moment in school, in work placements, and all through whichever route you go into. Just try as much as you possibly can.
Thank you. Can I pass that over to Rebecca? Thanks, Kate.
I would second Kate with that. I think don't be afraid at all to ask what kind of jobs are out there and who provides them. I was a bit shy at first about contacting different people, different consultancies, but don't be afraid. Send emails. Don't feel like you're nagging either, because it's for your own benefit. It's you want a taster of what you want your career to be, or what you don't want it to be. So for me, I was sending out emails before I managed to contact WSP. And a lot of them are so open to having you for the summer, or having you for 5 weeks, or for a couple of days a week after school. They are very encouraging, and it's something that I think helped me a lot in terms of confidence before I actually got a job in this career. It was the work experience was definitely good to get, and it's something that I feel uni encourages a lot more, especially schools. It should be a highlight of a year, or in my terms, a module. Definitely, we had to do it in uni, but it was something that is definitely worthwhile. I wouldn't take it back at all. It was great.
Thank you. And we're changing tack now. This question's come in from Mivy, but I think quite a few of you mentioned teamwork and working together has been something that's integral to everything that you do. But it was asking about, you mentioned collaboration, Mivy, and some of the work that you did. What do you think is the best example of that you've got in your career, was the question we've had.
It's difficult to think of a single good example, because I've worked in teams throughout my entire career, and one of the things I think is really interesting about the engineering process is working with other people actually results in a better solution. If you work in isolation, it's you're quite likely to miss something out. So even just the process of talking your ideas through with somebody else, and they'll say, well, what about this? You end up with a more complete solution as a result of it, and something you'd half thought of, you can end up including in that. And that's one of the things that's really important. But actually, what I spend a lot of my time doing is I work very closely with our customers. And they, you need to understand what it is they want from the solution, or even what their problems are. They might not be able to articulate their problems very well. So I work in partnership with our customers. I don't particularly like calling them customers because it sounds quite them and us, and that's not what it's meant to be. To listen and to understand. So communication is all part of that, and excellent listening skills. I've got a 7-year-old who talk about listening ears, having those listening ears, and understanding what the problem, because people can't always articulate that themselves. So kind of eliciting that problem, and then moving on to the solution and keeping that ongoing dialogue. So it's this constant collaboration rather than sort of going away and working in a very transactional model. And I just get a buzz out of working on as part of a team to work towards that solution as well. I find that very energizing.
Thank you. And Kate, you mentioned it's been different working in a team and actually being the youngest member of that team. That's the other question that's come in on collaboration. Do you mind if I come to you next?
Yeah, sure. I think for me, collaboration is recognizing the contribution that every individual has in a team, or not in your direct team, in extended teams. Everyone will have something to give. And sometimes it might feel like you have to promote that and make a point of that, and you might find yourself feeling young or in a minority and that you might get overlooked, but actually sort of the best teams I've been in have been ones that recognize every individual in them, and sometimes that's really challenging, and actually sometimes, let's be honest, it can be quite difficult to be in a minority in an environment, but actually engineering gives you a common language, and you can speak engineering no matter what discipline you're in, mechanical, chemical, anything. You all speak a very similar language, and that gives you a common grounding to build relationships on and to communicate. So I think that gives you a common starting ground to build respect and to build relationships in teams.
Thank you. I'm going to pass that over to Tash, because there's another question about how you've worked in your kind of role, and all the images that you showed, the visuals have been really well received. So thank you. Can you tell us a bit about your collaborative work with Dyson?
Yeah, absolutely. So I should say collaboration is built into the course, as I'm sure it is with many university courses. There's a lot of group coursework that happens, but I'm really glad that does happen, because when you think of, I'm going to talk about Dyson products because that's what I've been learning about. If you take, for example, a Dyson heater, the heaters that we make, they not only have to heat the air, but they have to transfer it around the room. So we have engineers who understand the heaters, engineers who understand the airflow through the system, engineers who understand materials that not just will give a nice finish, but that will also be able to withstand the heat of the heaters. The electronics engineers that look at the components that are going to go into this heater so that our users can decide when it's turned on and how hot it's going to be and that sort of thing. And I think if we couldn't all work together, there's no way we could make this one shiny looking product at the end of it. But I would say it's even not just about all sharing the same mindset. We also have engineers who might be more technical focused, but also engineers that might be more design focused, and engineers that might be thinking more about the user experience of the product overall as a package. And I think if you can't see that overall end goal, then it's really difficult to progress towards it, because otherwise, the people deciding um, how to make the heater itself work, how it's going to heat up, might decide that we're going to make it 100 degrees, and that's not what the user wants in their home, is it? They don't want the heat that comes out to be burning them. So I think it's really important that you have to keep that shared goal in mind throughout, but we use that to make something that's hopefully well received by a customer at the end of the day.
Thank you. I've got two more specific ones, then we've got questions to the whole panel before. I'm just keeping an eye on the time as well. So the next one is to Alice, and somebody eagle-eyed has been jotting down while you've been speaking and said about, you mentioned earlier on that research was not for you. Why was that the case? What kind of made you think that?
Well, it's really interesting, isn't it? So for me, and I have massive respect for people who work in academic research, but sometimes it can be quite a lonely path. And that was certainly my experience. So when I was doing my PhD, I was learning an unholy amount about the solidification of aluminium alloys and the very, very specific event of the nucleation of the solid material before it grew into solid crystals. And the way to study that was to freeze that very quickly and then be able to study tiny, tiny samples under an electron microscopy. So using a beam of electrons instead of a beam of light, to be able to really understand in very fine detail what was happening. And all that stuff that I've just described from beginning to end probably took about 4 months. And at the end of it was sitting in a darkened room with an electron microscope, where I took about 2 hours before my eyes were able to adjust to the darkness and I was able to use the equipment properly. Now, there were some amazing eureka moments. And my best moments were definitely when I was with the team. And in my case, the team was largely my supervisor, my industrial sponsors, and the customers for my industrial sponsors. But it's back to kind of understanding, you know, what suits you and what suits your way of working. And for me, I wanted to work in a much more collaborative environment. My particular line of research was quite not solitary, that would be saying the wrong thing, but it would also be wrong not to say you can spend a lot of time in labs on your own when you are at the sort of exquisite edge of scientific research. And I have massive respect for people that can do that, but it was not for me.
Thank you very much. And then the next one is for Kate. It's how do you think chemical engineering will change as things become more renewable and sustainable? For instance, what effect will cars become electric have on the catalytic converter industry?
I think, yeah, I mean, I think it may sound weird being in that sort of industry, but the best thing that could happen is that it doesn't exist anymore. Let's be honest, it would be great if we didn't need catalytic converters anymore because we didn't have combustion engines. And that is almost really exciting. It comes back to that in 15 years' time. I really hope my job doesn't exist. But the things I'm doing now will entirely stand me in amazing stead for whatever the future looks like. And actually, Johnson Matthey are doing some really interesting things now in hydrogen and in alternative ways of generating hydrogen. And the catalytic processes on the sort of molecule scale are very, very similar in many ways to the things happening inside of a catalytic converter. And so all of that knowledge, our science and research teams are doing amazing things at converting that knowledge into a future technology that doesn't exist now, but will potentially pave the way for the end of the combustion engine. But all of us and all of the skills we have are part of building that future. And I fully expect that in 50 years' time, that future won't necessarily exist anymore. So I think actually being in engineering just gives you the skills to apply to a huge range of different problems and different ways of working, and those problems are going to change because every time you solve a problem, you create or you find or you come across a new problem. So actually the mechanics of what's actually going on with the chemical engineering I'm doing at the minute don't necessarily matter. It's about how we do things and why we're doing things and what we're learning while we're doing them. And that is applicable through any sort of future that we come across. Engineering is always going to be a part of life. It's that applying the small scale science to the real world solutions that make an impact to people every day. The science on its own wouldn't have a global impact. You need engineering paired along with it to transform that into a change for people. And that's always going to be the case. I think I can't see a future where there won't be engineering at the leading edge of reducing our impact on the world, maintaining our position in the world. So yeah, I think the future is really exciting and really unknown, but that's part of the fun.
It is, isn't it? That's the exciting bit as well. Thanks, Kate. So the question that I've had, and I've saved it to the end because I thought so it's one of those reflective ones, which is, so it's our final one, is what advice would you give your 15-year-old self? Quite deep one to finish on. So just what advice would you give looking back over your career, of your, all that inspiration and all those role models you had? And I thought I'd start with Tash, if that's okay. What advice would you go back and give back in time?
Ooh, well, that's interesting, because I wouldn't necessarily say I'd change anything as such. So I think it would relate more to having the confidence to continue pursuing everything that's in front of me in that moment, and that everything that's inspiring me and giving me energy at that point. Because I think sometimes we can feel like people around us want us to go in specific directions. And I think it's important to remember that you need to go in the direction that you want to go in. And that might involve doing lots of different things. We've heard about how we might have lots of different hobbies that might be creative, and that might relate to what you end up doing in future. So even if you're thinking, oh, I might want to be an engineer, maybe I shouldn't do GCSE art, or I suppose A-level art at that point, still do it. It's all going to be relevant to wherever you end up, because if you're passionate about it, then I hope inevitably it will end up being part of your career.
Thank you. I'm going to pass over to Alice.
Oh, to my 15-year-old self, I would probably say, don't worry too much about not fitting in. I think I probably spent the first half of my career wearing dark suits and trying to dress subconsciously like most of the men in the room. And I don't do that anymore. That's for sure. And, joking, because I'm not that person, right? Most of my wardrobe is bright red or bright pink. And actually, this turns out there's quite a good benefit from that. If you're networking, if you're going out there, people remember you. You don't remember them because they all look the same, but they remember you. And actually, that could be quite helpful in a sort of business networking context. So easier said than done when you're 15, but don't worry too much about not fitting in or sticking out a little bit. Embrace it.
Thank you very, very much. Rebecca, over to you.
I think definitely I was very shy. I would encourage myself to reach out a lot more. I was a mature student in uni. Because of that, I didn't sort of reach out and ask people, my interests, and I was afraid. And then when I got to this career, I was sort of not intimidated, but there's a lot of men in this industry. A lot of in my office, I'm one of 4 women out of 40 men. So it is still quite. I was very, very nervous and worried how I would interact, whether that's going to affect my career. But I would definitely say no. Just go out and do it. Just be yourself and reach out. You'll be fine. It's a career. It's a lot less intimidating than you think, engineering, and it is what you make of it. So I definitely tell myself to be a lot more confident. Maybe I would have gotten there a bit earlier, but I don't regret it either anyway.
Thank you. It's so inspiring hearing these. Thank you very much. Mivi, would you mind sharing your advice?
I think scarily similar to Alice, actually. I think, when you're 15, you start thinking about the future and you realise that you're growing up and you can't slow that down. I think that's very daunting. I suddenly became very conscious about going into the adult world and finding that kind of troubling, and leaving the safety net of the family home and things. But really, I think I would love it if I spent more time. Okay, I'm going to feel a bit emotional saying this now. Okay, being myself, being all of the weird me that I am. Kind of say weird because we sort of feel obliged to fit into these stereotypes, and nobody does. People are very scribbly around the edges. And I still get it now. I think I don't know if you can see under these lights, but I've got pink hair and wearing a leopard print wiggle dress. It's not really what people think a coder looks like or a computer scientist looks like. I definitely spent some of my career being very self-conscious about my femininity. I'm 5'3", and it's you know, when you're kind of working, engineering is perceived as this kind of very masculine industry, and you know, who was I kidding if I thought I could emulate being a man? I don't want to be a man. I'm quite happy being a woman and a kind of a, you know, feminine. And I definitely kind of masked that about myself for a while, and I felt like I had to be serious in order to be taken seriously. And any frivolity or silliness, you know, I am a bit ridiculous and I'm a bit of a prat, and I think that ought to be okay. It doesn't mean that I'm not good at my job, and just recognizing that you're breaking the mold. I mean, I talked about Dame Stephanie Shirley as being a pioneer. I'm still a pioneer. I think there aren't many women at my level of seniority in the tech industry, and I think also just, you know, being unapologetic for being a nerd. There shouldn't be anything wrong about being passionate about your subject and enjoying learning. I mean, that's evidenced by all of the books around me, I think that should be something to be embraced. As I said before, that kind of, you know, we live in the kind of in a society where people can talk about their passion for the arts or for sport, but it's frowned upon a little bit if you talk about your passion for maths and the sciences, and those things are so important to us. I think that they shouldn't be something that's hidden. So anyway, long-winded way of saying, I think I wish I'd just be much more comfortable being myself, and all of what that meant. I'm going to have a little cry now because that's a very emotional thing to kind of say, even at my age.
Sorry. Thank you for sharing it though, because it is an emotional question. So thank you for sharing that. I really appreciate it. And Kate, what would you say?
I think a very similar vein, really. I think every single one of us on this call is completely different. All of you students, teachers, all of the panel, none of us are the same. We've all got different experiences, different backgrounds. I think a comment just popped up about learning disabilities. We are all just different people, and there is no one mold that will get you into a career in engineering. There's no one way of doing things. Everyone has their right way, be it apprenticeships, mature routes, graduate engineer. Like, we all did something different on the panel, and you will all do something different as students. And there is no one right way. So I think I would tell my 15-year-old self to be brave, to don't be afraid to do the thing that no one's done before. Go and do an A-level in Chinese, go and break boundaries, go and do something different that no one's thought of. Go and be the only female shift manager. Like, it doesn't matter if no one's done it before, because you can be that first person. And every single person on this call will be the first person to do something, and it might be something small that has a massive impact on you as an individual, or it might be something groundbreaking that changes the world. But you're never going to know until you look back at the end of your career at where you've been. You won't know you're doing it at the time. So I think just go for it. Just do the thing that's different, and don't be afraid that it doesn't follow a conventional path, or that you don't conform to the stereotype, or you're not doing something in the way that's expected of you, because we are all different, and we are all wonderful at being so different. So just go for it.
I'm getting emotional as well. I'm just hearing all of you speaking, and I think, and thank you for picking up on that question, Kay, because I think, and I don't want to speak for you guys, for the expert, but I would say that yes, you can. You, like Mary's put in there, can you go into this field even if you have learning disability? And I'm seeing lots of nods around there, and just that actually is that shouldn't be a barrier to anybody getting into this field. So I'm going to close it there, and if there are any more questions that come through, then we can pass those on and get some answers for people too. But I just wanted to take a moment and say thank you for the time tonight. I'm sure that everybody on the chat who's joined us would also join me in extending our heartfelt thanks to all of you. I've thoroughly enjoyed it. Your warmth, your inspiration, the insight that you shared for us, and also the practical tips as well. And I've scribbling down furiously. It makes me want to sort of have a career change. So maybe this is it for me as well. Maybe that will inspire me. And I wrote down, let's just dive in and do it. And that was really what struck me, is that engineering about making things happen. And all of the different tips have really, I can see everybody who's an aspiring engineer will take away a lot from it. So thank you for your time. I know it is very, very precious. Each of you has taken us on a journey tonight, and I'm sure, well, I've no doubt this is a definitive moment for some of our guests who are with us, and in the choices that they make on in their careers. So I hope that our audience will be able to join us for future talks as well in this series. A little plug for Mrs. Parish too, that our next Women Mean Business event will take place in the autumn term online, and that's linked to national security career pathways. And then there'll be following ones looking further at STEAM and at sport, so a lot to look forward to. Finally, if you're not a member of our school or a sister GDST school, you'd like to find out more about the school or about the GDST, then please do check out our website. As always, we'd love your feedback, so if you've enjoyed it or if there are things that you think we could do better, then please do feel free to leave your thoughts in the comments or drop us a line. Thank you to the wonderful Mrs. Parish, our amazing Head of Careers and Outreach, for organising this event, and to Jo Jepson, our Director of Marketing and Communication, for her support for the event. Thank you one more time, and have a lovely evening. Goodbye.